Ever wondered why some sports cars run flawlessly for decades, while others end up as expensive garage ornaments? The difference often comes down to what lies under the hood. The Toyota 2JZ from the Supra, Porsche's Flat Six, the Honda Acura NSX's C30A V6, BMW's S54 Straight Six, the Chevrolet LS Series V8, and Mazda's 13B Rotary have all earned legendary status. These engines did not just deliver mind-bending performance, they did it year after year with remarkable dependability. Today we are diving deep into what makes these 6 engines the most bulletproof power plants ever fitted to production sports cars. When it comes to sports car engines, reliability often takes a backseat to performance. Engineers push the limits of what is possible, creating power plants that produce astonishing horsepower figures, but sometimes at the cost of longevity. However, a select group of manufacturers manage to create engines that offer the best of both worlds. Exhilarating performance paired with tank-like durability that can handle hundreds of thousands of miles of spirited driving. These are not just good engines. These are engineering masterpieces that have stood the test of time, continuing to power enthusiast cars decades after they first rolled off the assembly line. From Japanese engineering marvels to American V8, muscle and German precision, these engines represent the pinnacle of reliability in the high-performance world. Toyota 2JZ GTE. The Toyota 2JZ engine might be the most famous reliable performance engine ever created. First appearing in the 1993 Toyota Supra, this 3.0-liter inline-six with twin turbochargers became an instant legend. The 2JZ was conservatively rated at 320 horsepower from the factory. But the real story lies in its incredible over-engineering. What makes the 2JZ so special? It starts with the cast iron block, a hefty foundation that provides exceptional strength and heat dissipation. Inside, Toyota installed forged steel connecting rods and a forged crankshaft that could handle forces far beyond what the factory turbochargers could produce. The closed deck design of the block provides superior cylinder seal and prevents distortion under extreme boost pressure. The 2JZ uses a sequential twin-turbo setup that delivers smooth power delivery throughout the rev range while maintaining excellent response. Even more impressive is that the stock internals can reliably handle up to 800 horsepower, with only supporting modifications like fuel system upgrades and engine management. This overbuilt nature has made the 2JZ the engine of choice for many high-performance builds. There are numerous examples of 2JZ engines with over 300,000 miles on the original internals, and tuned examples regularly push 1,000+ horsepower on the stock block. The aftermarket support is so vast that you can still build a complete 2JZ engine from scratch using new parts, despite production ending nearly 2 decades ago. The 2JZ has powered everything from drift cars to drag racers to time attack builds, proving its versatility across different motorsport disciplines. When properly maintained with regular oil changes and timing belt service, these engines can outlast the cars they are installed in. This incredible durability, combined with massive power potential, has kept values of 2 JZ-equipped Supras at premium prices in the collector market. Porsche Flat Six M64/01. Porsche's air-cooled Flat Six engines, particularly the M64/01 used in the 964 generation 911 Carrera, represent German engineering at its finest. This 3.6-liter, naturally aspirated boxer engine produces 247 horsepower and 228 pound-feet of torque. Modest by today's standards, but delivered with a mechanical purity that modern engines cannot match. The air-cooled design eliminates the complexity and potential failure points of water cooling systems. With no radiator, water pump, or coolant hoses to fail, these engines offer exceptional reliability in all conditions. The flat six configuration provides perfect primary and secondary balance, reducing vibration and stress on internal components. Porsche engineers were famously conservative with their power ratings, building engines that could run at maximum output indefinitely. The M64 benefits from improved oil flow and cooling compared to earlier Porsche engines, with larger oil passages and improved piston cooling. The dry sump lubrication system ensures critical engine components receive adequate oil even under extreme cornering forces. Many Porsche flat six engines have exceeded 300,000 miles with regular maintenance, with some well-documented examples passing the 500,000-mile mark. The key to their longevity is meticulous engineering and material selection. Porsche used aluminum alloys with silicon content for cylinder heads and magnesium for the engine case to optimize weight and heat dissipation. Maintenance on these engines is straightforward, but requires attention to detail. The air-cooled design means heat management is critical, and owners must ensure proper oil changes with high-quality lubricants. The valve adjustment is required periodically, but the accessibility of the horizontally opposed cylinders makes this job simpler than on many other performance engines. The Porsche flat six sound is also unmistakable, a mechanical symphony that builds from a distinctive burble at idle to a hair-raising wail near redline. This auditory character, combined with bulletproof reliability, has made these engines among the most sought-after in the sports car world. Honda, Acura, NSX, C30A V6. When Honda decided to build a supercar in the late 1980s, they turned to Formula One for inspiration. The result was the C30A V6 engine that powered the first-generation NSX, a 3.0-liter masterpiece that combined exotic performance with everyday reliability. The C30A features an all-aluminum block and heads, titanium connecting rods, a first for a production car engine, and Honda's VTEC variable valve timing system. This 270 horsepower V6 revs to 8,000 RPM with the smoothness and eagerness that became Honda's trademark during this era. What makes this engine extraordinary is not just its technical specifications, but how it delivered supercar performance with the reliability of a family sedan. Honda's engineering philosophy meant testing the NSX engine to extremes, including running it at redline for 24 hours straight. The C30A uses a 90-degree V configuration with primary balance shafts to eliminate vibration. The extremely rigid aluminum block maintains perfect alignment of the crankshaft and bearings even under extreme conditions. The VTEC system provides two distinct cam profiles, one optimized for low RPM efficiency and another for high RPM power, creating an engine that is both tractable around town and exhilarating on a racetrack. Timing belt services are required at 90,000 miles, but otherwise the C30A requires minimal maintenance beyond regular oil changes. Many NSX engines have exceeded 200,000 miles without internal repairs, with some documented examples reaching 300,000 plus miles on original internals. The C30A represents Honda's engineering prowess at its peak, a time when the company was dominating Formula One and bringing that racing knowledge to road cars. This engine proved that exotic performance did not have to come with exotic reliability problems, forever changing expectations for supercar ownership. BMW S54 straight six. The BMW S54 inline-six engine that powered the E46 M3 2000 to 2006 represents the pinnacle of naturally aspirated six-cylinder engine development. This 3.2-liter masterpiece produces 333 horsepower and 262 pound-feet of torque, revving to an impressive 8,000 RPM with buttery smoothness. BMW's engineering excellence shines through in the details of the S54. It features individual throttle bodies for each cylinder, providing razor-sharp throttle response. The double Vanos variable valve timing system adjusts both intake and exhaust cam timing for optimal performance throughout the rev range. A high-flow cylinder head with finger followers instead of traditional bucket tappets allows for higher revs with less valve train mass. The block is cast iron for superior strength, while the cylinder head is aluminum for reduced weight. This combination provides excellent heat dissipation and durability. The connecting rods are iron with steel bolts, and the crankshaft is forged steel, all overbuilt for the power level the engine produces from the factory. While early S54 engines had issues with rod-bearing wear, BMW addressed this with updated specifications, and properly maintained examples regularly exceed 200,000 miles without major issues. The key to S54 longevity is frequent oil changes with high-quality synthetic oil and a regular inspection of the Vanos system. The most impressive aspect of the S54 is how it delivers its power. The torque curve is remarkably flat, providing usable thrust from just above idle to redline. The engine note is intoxicating, a mechanical growl at low RPM that builds to a spine-tingling wail as it approaches its 8,000 RPM redline. BMW's S54 proved that naturally aspirated engines could deliver exceptional performance while maintaining excellent reliability when properly engineered. This engine helped the E46 M3 earn its reputation as one of the greatest driver's cars ever created, with a mechanical character that modern turbocharged engines struggle to match. Chevrolet LS Series VA8. The Chevrolet LS series of V8 engines represents American engineering at its finest, combining simplicity, durability, and outstanding performance in one package. First introduced in the 1997 Corvette, the LS1 5.7-liter V8 produced 345 horsepower and has evolved through multiple generations. What makes the LS series so remarkably reliable? It starts with the architecture, a cam and block design with push rods operating 2 valves per cylinder. While this might seem old-fashioned compared to overhead cam designs, it results in a compact, lightweight engine with fewer moving parts to fail. The aluminum block, in most variants, provides excellent strength-to-weight ratio, while the deep skirt design and cross-bolted main caps ensure exceptional rigidity. The LS uses cathedral port cylinder heads with excellent flow characteristics, allowing for impressive power production without extreme compression ratios or valve timing. The firing order was optimized for smooth operation and even cylinder cooling. The distributor-less ignition system with individual coil packs eliminates another common failure point found in older V8 designs. Perhaps most impressive is the versatility of the LS platform. These engines have powered everything from Corvettes to Camaros to numerous other GM performance vehicles. The aftermarket support is unmatched, with countless upgrade options available. Stock LS engines regularly exceed 300,000 miles with basic maintenance, while modified examples have proven capable of reliably producing over 1,000 horsepower with appropriate supporting modifications. Maintenance requirements are remarkably simple. Regular oil changes and occasional tune-ups are all that is typically needed. The robust bottom end rarely requires attention, even in high-performance applications. This simplicity and durability have made the LS engine platform the default choice for engine swaps into countless project cars across all brands. The LS demonstrates that cutting-edge technology is not always necessary for reliable performance. By refining a time-tested design with modern materials and precision manufacturing, Chevrolet created an engine family that delivers exceptional reliability, along with the characteristic V8 rumble that enthusiasts crave. Mazda 13B rotary engine. The Mazda 13B rotary engine stands apart from everything else on this list. As the only non-piston engine in mainstream production cars, the Wankel rotary design used in the RX-7 and RX-8 breaks all conventional rules of engine design. The 13BREW twin-turbo variant used in the FDR-X7 produces 276 horsepower from just 1.3 liters of displacement. This incredible power density comes from the rotary's ability to produce 1 power stroke per revolution of the eccentric shaft, equivalent to the crankshaft in piston engines. The twin sequential turbochargers provide smooth power delivery throughout the rev range. While rotary engines have a reputation for being finicky, properly maintained 13B engines are remarkably reliable. The key is understanding their unique requirements. The rotary has just 3 main moving parts, 2 rotors and an eccentric shaft, compared to dozens in a piston engine. This mechanical simplicity contributes to excellent durability when properly cared for. Regular oil changes are critical for rotary longevity, as the engine uses oil for apex seal lubrication. Pre-mixing fuel with 2-stroke oil is a common practice among enthusiasts to provide additional lubrication. The cooling system must be maintained meticulously, as heat management is crucial for preventing premature apex seal wear. The 13B rewards owners who understand its quirks with a driving experience like no other. The engine revs with almost no resistance, spinning up to 9,000 RPM with turbine-like smoothness. The compact size and light weight allow for perfect weight distribution and a low center of gravity, giving RX-7s and RX-8s their renowned handling balance. Many 13B engines have exceeded 150,000 miles with proper maintenance, with rebuilt examples lasting equally long. Mazda's continued development of the rotary over decades resulted in significant reliability improvements, with the later series engines addressing many early weak points. The Mazda rotary represents engineering persistence in the face of conventional wisdom. While the design has inherent challenges, Mazda's dedication to refinement created a reliable exotic engine that delivers a driving experience no piston engine can match. These 6 engines represent the pinnacle of reliability in the sports car world. From the overbuilt Toyota 2JZ to the precision-engineered Porsche Flat 6, the exotic Honda C30A to the bulletproof Chevrolet LS, and from the sophisticated BMW S54 to the unconventional Mazda 13B. Each demonstrates a different approach to achieving the same goal, delivering exceptional performance without sacrificing durability. What unites these diverse power plants is the engineering philosophy behind them. In each case, manufacturers prioritized robust design and quality materials over maximum output. The result is engines that not only meet their performance targets, but exceed them while providing reliability that owners can count on year after year. For enthusiasts, these engines represent more than just mechanical components. They are the beating hearts of vehicles that have become cultural icons. Their longevity has allowed generations of drivers to experience the thrill of sports car ownership without the financial burden traditionally associated with high-performance vehicles. If you enjoyed this exploration of the most reliable sports car engines ever made, please hit the like button and subscribe to our channel for more deep dives into automotive engineering. Share your experiences with these engines in the comments below. We would love to hear your stories. Thanks for watching, and we will see you in the next video.